Hello and welcome to Systems of Equations. Alright, this is going out during our Thanksgiving break. Hopefully you're having a good one. But it's also to help you not lose track of where we were. So, with a word problem. The cat's chasing after the mouse. We called this one in class the zombie problem, but a few years ago it was cat and mouse. So, cat runs 6 feet per second, mouse runs 4 feet per second. Mouse has a 10-foot head start. How long will it take the cat to catch the mouse, and where? How far from the start will the cat catch the mouse? So as you guys know from class, we could solve this like the zombie problem with a graph. You can act it out, you can make a chart, lots of different ways to do this. But I'm going to show you how to solve it with substitution. In order to solve it with substitution, we need to come up with an equation. So, actually 2 equations. I'm going to make an equation for the cat, and I'm going to show you how the cat's distance is equal to, let's see, the cat runs 6 feet per second. So that's its slope, and we don't know the time, so I'm going to call that t. So 6 times t, and the cat does not have a head start, so if you want to put plus 0 you can, but I'm not going to. And then the mouse, the equation for the mouse's distance is it runs 4 feet per second, so that's the mouse's slope. We don't know the time, but it has a 10-foot head start, so we have to add that in. So, like we talked about in class, if we have d equal to something and d equal to something, but it's 2 different somethings, well, doesn't it make sense that we can set d equal to d? And what I mean by that is this distance, I'm going to substitute what it equals, 6t. And this distance, I'm going to substitute what it equals, 4t plus 10. And once you're done that, well, now we have an equation. We only have one variable, this t, and we just need to solve for it. So draw your lines, guys. It's a variable party. Again, lots of ways to start this problem. I'm going to start by subtracting 4t from both sides. 6t minus 4t is 2t. And this is a hua. Then we have 10. Divide both sides by 2. Divide both sides by 2. And we have t is equal to 5. And that's great, because we realize that it's going to take 5 seconds. But that doesn't totally answer the questions, because it says, how far from the start will the cat catch the mouse? In other words, we need to find the distance. So I'm going to take this value, plug it in to that equation because it looks very easy for me. So it's going to say distance is equal to 6. I'm not going to write t. I'm going to write what t equals, 5. So we have 6 times 5. Distance is equal to 30. So we're talking about feet. So that means in 5 seconds and 30 feet, cat catches the mouse, or the zombie killer catches the zombie, if you prefer. Alright, yes, all that work, you require a little break. Watch out for sharks. Okay, we're going to solve this one by substitution. It's a little different. Now, let's talk about what I noticed, because you want to take some time to notice. Notice that this x is by itself. In this equation, there's nothing by itself, so we're not going to substitute in with that equation until we have something. Oh, and then look, we have y by itself. That is good, because what that means is now I can rewrite this equation not with x and y, but I'm going to write, just since we know what y equals, it equals all of this, I'm just going to write what y equals instead. So 3x plus 4, not going to write y, I'm going to write what y equals. What does y equal? It equals this. So I'm going to put my parentheses and put that where y is. And it equals 7. And that's great, because now, in this equation, all we have are x's. So we can solve it. I do see we got a little hua action going on here. We have that number outside parentheses, so we're going to distribute. That gives me 3x plus 4 times x is just 4x. And 4 times 3 is 12. Next, do we have any like terms? I see like terms. Since they're on the same side of this equation, we're not doing the opposite. We're going to combine them because they're together. So it's like 3 teenagers here, 3 teenagers here. Combine them, we have 7 teenagers, or 7x plus 12 equals 7. Then you're like, oh, this is so easy now. Just subtract 12, and we get 7x is equal to -5. Now you might be thinking, whoa, did I do something wrong here? This looks weird. But the answer is no. Sometimes you get fractions in your answer. So we get final answer here, x is equal to -5/7. But not done. What we're going to have to do is take this x, plug it back into, it could go into either equation, but you take a look at that and tell me which one you think is easier. I'm going to plug it into this one. And I'm going to do -5/7 plus 3. Can't forget our fraction stuff. We have to solve for y here. In this case, the sign's not the same. We have a negative and a positive, so that means we're going to subtract 3 minus 5/7. Well, change 3 into 2 and 7/7. And when I take 5/7 away from it, I get 2/7. And then since I turned that 3 into 2 and 7/7, I can do that because 7/7 is 1. 2 plus 1 is 3. So if I do that, subtract the 5/7 from it, I get 2/7. So it's going to leave us with a final answer of 2 and 2/7. So we put it together, make an ordered pair. -5/7 x, 2 and 2/7 y. Now we can look to what we're going to do when we get back, and that's solving with elimination. So sometimes you can graph to solve, sometimes you can use substitution, sometimes it's really easy to solve with elimination. Watch this. So what we're going to do is we're going to treat these like the x's, and this is in standard form, so this is a real easy way to do elimination because my x's are lined up, my y's are lined up, numbers lined up. So that means we can just combine them together to add down. 5x and 3x is 8x. Here's why this is perfect for elimination. If we have the opposite of y and y, if we add that, we get 0y. And then 0 plus 24 is 24. And when we do that, there's no more y. Hey, we know how to solve this. Pretty easy. X is 3. Did you get all that? We just added down. These two were eliminated, thus it's called solving with elimination. These two added down to get 24. Solve for x. But now, no, we're not done. We're going to take this, plug it back into the equation, and solve. So I have, whoops, I'm sorry, I drew that in the wrong spot. It should go where the x is, not where the y. Sorry about that, but it would be 5 times 3 minus y equals 0. And I'm going to add y to both sides just to make this easier to solve. So that gives me 5 times 3 is 15 is equal to, hey, this is a y, that's a y, so I have my ordered pair, 315. Okay, and again, if you're not sure if it works, let's just plug it back in and solve it. Let's plug it into the the equation that we haven't really been working with, which is right here. So 3 is my x, 3 times 3 is 9, plus 15 is my y. 9 plus 15 does equal 24. We are right. Unfortunately, though, sometimes elimination looks like this, where they're just not so easy to add down, because none of these are going to cancel each other out like that nice 9y and 8y. So what we could do is, I see that these have opposite signs, so that's a little bit easier for us. But negative 9y and positive 8y are not going to cancel out unless we have them kind of like a common multiple. So if I had between 8 and 9, the common multiple is 72. So what do I have to do to get this equation here, this to be 72 and this to be 72? Well, what I have to do is I have to multiply this whole equation by 8, and I have to multiply this whole equation, let me choose a different color, this whole equation by 9. Then watch how easy it is to eliminate. So I'm going to do this, and this is kind of a distribute, 8 times 5 is 5x is 40x. 8 times negative 9 is negative 72y, which is what we wanted. And 8 times 43 is 344. But negative 344. Okay? So again, we're trying to eliminate. So let's do a little hua here. 9 times 3 is 27x. 9 times 8 is positive 72, and that's what we wanted, because notice above it is a negative 72y, and that's going to cancel out. It's going to get eliminated. And then we have 9 times 68, which is 612. Okay, so we have these two equations. If we just add down, we can eliminate this y variable, because 40x plus 27x is 67x, and then 612 minus 344 is 268. These, of course, get eliminated. And the way we solve this, we're just going to divide by 67. And oh my gosh. And then divide this side by 67. And we get, let me get some room here. X equals 4. But remember, not done. Now, you can use this x and you can substitute it into this equation, this equation, this equation, or this equation. We have choices. I'm going to insert it into this equation right here. Okay, so I have 3 times 4 plus 8y is equal to 68. Let me give myself some room. Okay, 3 times 4 is 12, plus 8y is 68. Let's get this 12 out of here, because I want 8y by itself. 68 minus 12 is 56. And if we divide both sides by 8, we get y equals 7. So we have an ordered pair of 4, 7. Let me take it back to our original problem. 4, 7. I'll put it up here. 4, 7. And again, you could always just check that. If we plug it in, 4 times 5 is 20, minus 7 times 9 is 63. 20 minus 63 is negative 43. We're right. Okay, guys. Hope to see you on Monday when we get back. Review a few of these problems, and then maybe you'll remember some of the stuff and be able to pick up where we left off. Have a great break. See you guys.